Welcome back to our channel. Today we are going to see about definitions of a point in n space, n-dimensional space. So we say that a point is just a location or a position in a space with no size or dimension, so typically which is represented by a dot and which is labeled with capital letters. So for instance, in one-dimensional space, so one-dimensional space is isomorphic to a line, or which there is a one-to-one correspondence between a line and the 1D. So in one-dimensional space, a point is just a number, so which is denoted by this dot here and labeled by this one. So any point or any number in a number line is a point in one-dimensional space. So if you have given 2 points on a line or in 1D, then we can compute the distance between them by using this formula here. So which is the distance between A and B is given by absolute value of B minus A. So we use this absolute value because distance can never be negative, so we use this one. So for example, if you have this one, let's say -4 and let's say 2, the distance between -4 to 2 is, as you see here, so we have 2 here and we have 4 times, so we expect the distance should be 6. So using the formula, so the distance between -4 and 2 is given by absolute value of 2 minus -4, so which is 2 plus 4, which is absolute value of 6, and absolute value of 6 is 6. And similarly, for two-dimensional space, a point is just an order pair, x naught, y naught. So if you have a point in x, let's say x naught, and if you have this y naught here, then a point in a plane or in two-dimensional space is just this point here, so which is x naught, y naught. So the representation of a point in 2D is the order pair x naught, y naught. And a similar way, we can define the distance between 2 points in R2 or in two-dimensional space is given by this formula here, so which is given by, if the points are P, let's assume that point P is given by this and point Q are given by this, then the distance between this P and Q is given by the square root of x1 minus x naught the whole square plus y1 minus y naught the whole square. So for example, if you have given this point 1 minus 1 and a point 4 0, then we can calculate the distance between these 2 points, so which is given by PQ, which is 1 minus 4 the whole square plus -1 minus 0 the whole square, similar to -3 square, which is the same as 3 square, plus -1 square is the same as 1 square, so which is the square root of 10. So we have 10 units. You can say this one. So we can calculate the distance using the formula here. So in a similar way, in 3D space or in three-dimensional space, which is similar to the Euclidean space R3, and geometrically we can represent 3D space by using this here. So we have x, y, and z. Then we can locate a point ABC in 3D like this. So if you have a point A in the x-axis, and you have B the y-axis and C in the z-axis, so we can have this one. So these are perpendicular 90, so they make 90 degree everywhere, and this also it makes 90 degree. So a point is located, represented by this PABC. So if you have 2 points again, P and Q, in R3 or in a 3D space, then the distance is given by this. So you can just do this one. So the distance between P and Q is given by this, which is the square root of 1 minus minus 1, 1 minus minus 1 the whole square, plus 4 minus minus 2 the whole square, plus 0 minus minus 3 the whole square. So which is the same as the square root of 2 square plus 6 square plus 3 square, which is square root of 4 plus 36, plus 9, which is equal to the square root of 49, which is 7 units. So the distance between these 2 points is given by, which is equals to 7. So in general, we can represent a points in n space as n tuples of numbers. So these are n tuples of numbers, and we can call each coordinates like this. So the first one is, we can say the first coordinate, so which is this one is the second coordinate, and so on. So we have the nth coordinate. So that means, so any point in n space or in n dimensional space is just n tuples of numbers, and the distance between 2 points in n dimensional space is given by this one, the formula here. So knowing about points also helps us to find, for instance, the volume of a solid figure, or if you know the 2 points, you can find the equation of a line or anything else. So that means a point is everywhere, or they are important for anything in mathematics or in other sciences. So for instance, if you have given this solid figure, a rectangular solid figure, and as you see that each corner has a point representation. So if we know this one, we know the point representation of each corner has a point representation. So using these points, we can find the volume. So as you know, the volume of the solid figure is given by area of base times height. And since our base is a rectangle, so we can you can just use this one here. So this is the base, and you can take any of this side, either this one or you can use this one. Then you can find the volume of this solid figure, the rectangular prism, which so what's the area of base means, since it's a rectangle, so which is length times width. So we can have PA, side PA, or the distance between these 2 points P and A, it's a line segment, and the distance between AB, times you can use either AC or you can choose BQ. So for me, I choose BQ. So PA, the distance between P and A, is given by what? 3 minus 3, which is 0 square, plus 4 minus minus 1, which is 5, which is 5 square, plus minus 2 minus minus 2, which is 0 square, times, and the distance between A and B is minus 3, which is minus 6, same as 6 square, plus 4 minus 4, which is 0 square, and minus 2, then plus 0 square, times the height, which is BQ. So the distance is minus 3 is 0 square, plus 4 minus minus, which is equals to again 0 square plus 2 minus minus 2 is, which is 4 square, so which is the same as 5 times 6 times 4, which is 120 cubic unit. So the volume of this rectangular prism is 120. So the next is how can we define an operation operation for points in any dimensional space. So if you have 2 points, this A and B, so which are points in any space, and if you consider this alpha be any real number, then addition of points is a point by itself, and which has this representation. So we just add up each coordinates simultaneously, and the point representation of addition of 2 points is given by this one, and the scalar multiplication is again given by this, so which is a point and it has this representation, so which is we are multiplying any coordinate by the scalar alpha. So these two operations have the following properties. So as you see that addition of 2 points is commutative, so this one is, we call it commutative property. So if you have A and B, then A plus B is the same as B plus A, and also addition of points is associative, so we call this is associative property. And the third and the fourth are, we call it distributive. So here multiplication is distributive, so we can distribute this scalar multiplication like this, and for this one we can distribute these points on this addition, the scalar, the addition of scalars. So we call this the property 3 and 4, we call them distributive property. And if you have a point and if you have a 0 point, so when you say 0 point, which are n tuples of zeros here, or each coordinate has a value 0, so adding 0 to any point gives you the point here. So this one is, we can say that existence of identity, and our identity here in the case of addition is 0. And multiplying a point with a real number 1 is always the point, so this is a number 1, so multiplying this one by 1 by a point A, which it gives you the point A. And using this property 5, we can also have A plus minus A is equals to 0. So here 0 is the 0 point, not the 0 number. So in this case we call this is inverse, additive inverse of a point A. So you can try this one by yourself.